Okay, today let's talk about the memory power supply of the group power supply. In fact, when the memory is working, not only the main power supply is required, it also needs two power supplies. Memory mainly depends on the three main power supply to complete the work. There are three main voltages for memory. One is SPD IC power supply. Everyone knows that there is a small 8-pin IC on the memory stick. This 8-pin small IC is for storing basic information of memory. This power supply is on our Apple MacBook. It is 1.8 volt. It is produced by the 1.8 VSO in Apple MacBook, and it is 3.3 volt on our Windows computer. It has a dedicated IC circuit to complete. Wait a minute, we will analyze how this circuit is generated. We talked about the main power supply of the memory in the last class. Core DDR REG 1.2 volt. This is what we talked about in the last class. There is voltage. We will analyze the power supply next. In addition, the reference voltage of the memory was mentioned when the main power supply was discussed in the previous lesson. Its name is marked as DDRVTT on the circuit diagram. The reference voltage is half of the main power supply. If our 4th generation memory is 1.2 volt, it is 0.6 volt. If our main power supply is 1.5 volt, the 3rd generation memory is 1.5 volt. Then it becomes 0.75 volt. It changes as the memory changes. And the memory reference voltage, there are only two ways on the MacBook at present. The first way, it is generated by the internal voltage stabilizer of the memory power supply IC. This is the DDRVTT, that main power supply of the memory we sent out last class. When you analyze the memory power supply, it will send out DDRVTT out. In other words, you are inside the power supply IC of the memory. If you analyze the main power supply of the memory, DDRVTT appears. That is, when we talked about the memory main power supply in the last class, there is mark on the drawing. As long as there is no DDRVTT, it refers to its reference voltage. This is the first way. The second way has a separate IC. Actually, the internal regulator is integrated internally. This is the main power supply IC for the memory. This way it says closed. The second method also has a separate IC. The voltage stabilizer is not built in the type IC, but an independent IC. Also, you see a chip next to it, and the independent chip write DDRVTT. This is an independent IC. In other words, the memory requires 3 voltage, and it cannot work without any one of them. Or will cause our laptop to no boot. And we talked about the main power supply circuit in the last class. It is this reference voltage. Then let's analyze the 1.8 VSO of the memory. How does it generate this variable pressure with memory? If the power supply is broken, it will also lead to no power on. Next, let's take a look at the memory SPD power supply through the circuit diagram, how it works. Let's look at this circuit diagram. This is a working circuit that supplies power to the memory SPD IC. On this inductor L7720, it measures 1.8 volt. The voltage on this inductor is SPD IC of the memory. When everyone turns on the MacBook memory, the memory stick has a small 8-pin IC, which is our SPD IC. It stores our basic identifier information in memory. If the power supply is damaged, we will not be able to boot. Take a look at the L7720. It measures 1.8 volt on the circuit diagram here. This is a model U7720 powered by our memory pull-up power supply SPD IC. In fact, upper and lower tubes are integrated inside the IC. Its main components can also be seen in the circuit diagram. It is made by our large inductor L7720 and our U7720. To analyze this circuit, we only need to analyze that. If the voltage on the test inductor is not 1.8 volt, that means this circuit has been damaged. Then let's analyze how this IC works. Look at the picture above. After triggering, the IC gets power first. The first pin, the second pin, and the third pin are powered. Then the IC will generate a good signal in the second step. Switching signal 3.3 volt. With this switching voltage. Then this is 3.3 volt. Yes, this is just a name, no working voltage parameter. I want to emphasize that it is just a voltage name. Don't think it must be 1.8 volt. If it is marked with the 1.8 volt, we have to look at the switch signal. All switch signals on the MacBook are 3.3 volts by default. The second condition is met. Then the IC starts to work and outputs a square wave. Charge and discharge this inductor. If conditions permit, you can use an oscilloscope to measure whether a square wave is formed on this inductor. Then through the capacitor field C7723, including the C7721 capacitor, 2 capacitors for filtering and connecting to ground, capacitor for filtering. For a direct current to generate 1.8 volts for the SPD power supply IC of the memory. FB here to play a feedback role. These 2 resistors are under maintenance. Don't follow R7720 and R7721. Of course, these 2 resistors are unlikely to be broken. In maintenance, when everyone is replacing this IC, be careful not to lose or fall off these 2 resistors. We have to make it up. There is an error between the 2 resistors. We should pay attention to the error of 1%. This is memory. After the inductor voltage is normal, the IC will send out a good signal. PG signal goes out. We will not emphasize this PG signal in this lesson. We will talk about what the PG signal is used for later. This lesson is not focused on analyzing the PG. Everyone knows that there is a PG output. It should also be 3.3 volt. In other words, after the IC works normally. Finally, it will output the PG signal out. What is it for? Used as a switching signal for the backport circuit. If there is no such 3.3 volt output, we have to change the IC at this time. After the inductor voltage is normal, the IC is normal. After the IC is normal, and what shall we go to? To test the PG pin, that is, whether our 7th pin has a 3.3 volt. If there is 3.3 volt, it means that our IC is good. If we look at the 4th pin, it's the synchronization signal. The sync signal pin is under maintenance. Generally, we don't test it. The probability of damage to this synchronization signal is relatively small. The signal to be measured in the future is power supply. The 1st, 2nd, and 3rd pins of the power supply. These capacitors are relatively easy to damage. We have to dig it up, also don't need to install it. Both the C7720 and the C7724 capacitors play a filtering role. Before changing the IC during general maintenance, we will deduct these 2 capacitors. Check if there is any leakage of capacitor that will cause the IC to doesn't work. As can be seen from the figure, the circuit is relatively simple to work. Maintenance is relatively simple. The most vulnerable thing here is the C7720 IC, how this circuit works. The power supply method is the same in the later. Including the power supply of the bridge, the working principle is the same. In the maintenance, we measure the inductor if it is about 1.8 volt. That means that the circuit is no longer problematic and there is no need to repair it. This is the working principle of the SPD power supply IC of the memory. Okay, let's go on. Everyone has probably learned from what we said in the last class. Our laptop has standby first and then trigger. After trigger, there is memory power supply. bridge power supply, and CPU power supply. We finished the analysis of the several power supplies of the memory in the last class, including how to repair. Then let's talk about the power supply of the bridge. The current new MacBook integrates the bridge and the CPU in appearance. In other words, you may not see the independent bridge coming out of the current new MacBook. Even if they are combined, the power supply of this is in order. We first check the power supply of the memory, and then we check the power supply of the bridge. After checking the power supply of the bridge, check the power supply of the CPU. Next, we look at the power supply of the bridge. It is also divided into several types on the MacBook. There is main power supply and auxiliary power supply. Our auxiliary power supply is relatively small, usually 1.5 VSO or 1.05 SO. Marked SO means it is working in the SO state. These two kinds of power supply are directly generated by the power supply IC in the figure. And main power supply is different. It is generated by the power supply IC controlling the upper and lower tubes. It is generally called VCCSA in English. In general maintenance, its main power supply has a large inductor and it is connected with the large inductor. Large inductor will have the word VCCSA. But this tool will not be marked. There is no large inductor. Maintenance is also very important. It is necessary to look at the drawing for analysis to find. If these two are not behind, then the power supply of this back end and the CPU power supply don't need to be checked. Because it has a logical sequence, we have also mentioned it just now. Next, we will look for it through the drawings. How does bridge power supply and main power supply work? How does auxiliary power supply work? This part is the power supply of the bridge. Let's take a look at the working principle of this part of it. Zoom in. Take a look, it is powered by the main IC. The power supply IC U7100 of the bridge and the set of upper and lower tubes Q7100. In addition, there is a L7100 energy storage charging and discharging inductor. There is a precision resistor next to it. Look at the precision resistor R7140. The method of the detecting it is the same as insurance, but it cannot be short-circuited. Remember, when encountering the beginning of the word 0, this kind of resistor is 0.9. On the MacBook, its measurement method is the same as that of the insurance, but it cannot be short-circuited. It is different from ordinary insurance resistors. An ordinary insurance resistor can be short-circuited. This kind of resistor of a few tenths of an ohm is called precision resistor, also called current sensor. Don't short-circuit during maintenance, and it is relatively easy to break. Similar to the R7140. On Apple MacBooks, as long as the circuit where the inductor is located, there are basically such electrons. Generally, we do not have this kind of resistor on Windows computer, just a little bit less. Analyze the power supply of the bridge. Look at its English PPRVCCSA SO. What does SO mean? It was completed in the state of SO. When I talked about the trigger circuit, I mentioned S5, S4, S3, and S0. It will be in S0 state. Let's take a look at this voltage. To analyze this circuit is to analyze how this U7100 works. Let's take a look at U7100. It also needs power supply. Pin 19 and pin 20 are its power supply pins. In other words, after triggering, this pin must receive electricity firstly. It comes from 5 volts. Remember that this R7100 is relatively easy to break, 2.2 ohm. If it is found that the resistor is easy to burn during maintenance, it will still burn after changing new one and still burn the resistor repeatedly after replacing another. 90% of the IC internal leakage causes the resistor to burn out. This resistor can't be short-circuited either. Many people think it is an insurance resistor and shock it out because it has an error of 5%. So when many repairers are repairing it, they don't take this error into consideration. Short it up directly, it will cause short-circuiting and burning. Short-circuiting and burning one. Avoid this situation as much as possible. We'll come back to look at the drawing. After the IC is powered, it will receive a switch signal. Look at the pin 15, it is also 3.3 volt. In other words, when 3.3 volt is being repaired, if there is no 3.3 volt, you have to find out this VCCSA. This EN is sent from the certain components of 62. Just 5 is superior. In addition, it has 1. The second step, after having the switch signal, it will have a self-exciting power supply. There is a self-excited power supply on the pin 18. 18 pin resists the self-excited power supply. Where does this power come from? Everyone take a look. Charge and discharge through 07130 with our 16-pin output square wave. This capacitor is absolutely indispensable and don't short circuit. This capacitor is equivalent to the compensation voltage. After charging and discharging this capacitor, send it through this 0 ohm resistor, 0 ohm resistor R7130. This resistor is also easier to burn and the capacitor should not be short circuited during maintenance. The resistor error is within 5%, which is alright. Try not to short circuit, try to install it. Apple MacBook is not our ordinary notebook. It has stricter requirements for current and voltage precisions. Try not to short circuit this kind of resistor. Then there is a key signal pin, remember the 4th pin. This oscillation signal pin is equivalent to the clock signal. There is an oscillation signal pin RTN, let's take a look. It is connected to this pin with an R7153. This is an oscillation signal pin connected to ground, equivalent to the clock pin. This resistor can fall off, it must be replaced. We must master these small details. In addition, it also mentioned the FB problem here, feedback signal. The components of the feedback pin are the same. There is an R7151 resistor. The resistor itself is not broken much, that is, we are not careful and rigorous enough in the maintenance. Like peripheral resistors, such as R7141 20 kilo and R7148 resistor, is not bad unless it gets into water. Basically, it won't be broken without getting water. What is most likely to be broken generally? In repair, the resistors of about 0 ohm are more likely to be broken. After this IC resists boot, after 18 pins receive boot, then the outputs are square away. In fact, as long as there is a kind of circuit of upper tube and lower tube, its working principle is the same. It's just a different module and working voltage is different, but the maintenance method is the same. What signal does it output? Here it outputs a square wave to control the upper tube conducting first. Here the G pole of the upper tube. Here this is a 4th step. If there is no square wave, then there is a problem with the IC. The upper tube is turned on firstly to charge the inductor. After the L7100 is fully charged, the lower tube is turned on again. Then output the square wave to the G pole of the lower tube, and the 2 tubes are turned on in turn. This is also square wave. The inductor has a filtering effect and is filtered into a direct current. Pass a polar capacitor C71141 again. This R0.01 is a precision resistor, meaning to detect the current of the light. Then one is forward current and the other is output current. These two currents are being calculated and adjusted by the IC. The voltage generated is sent to the inductor. The main power supply of the bridge that produces it appears here. So if during maintenance, it is measured that there is no voltage on the inductor on the bridge, how much volt should it be? Take a look, mark 1.05 volt on this inductor on the drawing. If there is no 1.05 volt on the inductor, it means that the circuit has been damaged. It's the same when we repair it, we have to check the resistance value. See whether it is caused by the short circuit, open circuit, or connect circuit to deal with. It is the same as the maintenance method and the main power supply of the memory. So the main power supply of the bridge is relatively simple to repair. We should also pay attention to it. Generally easy to break. It may be the precision resistor in the circuit. Draw it for you. Precision resistors are easy to break. The capacitor is easy to break. 3. The upper and lower tubes are easy to break. 4. The IC is easy to break. 5. These two resistors, the resistor of 2.25 volt. 6. And this 0 ohm resistor is also easy to break. There is also an EM pin. The upper level IC connects. It is also relatively easy to break. If there is no 3.3 volt, this IC won't work. So this circuit is relatively simple to repair in the entire circuit of MacBook. As long as this kind of power supply circuit with large inductor is relatively easy to break. So this kind of power supply mode we also mentioned in the last lesson. Be sure to learn this circuit mode and this switching power supply well. The subsequent repair methods are the same, including memory power supply, bridge power supply, CPU power supply. Its principles are the same, but the working voltage is different. Therefore, during maintenance, everyone should focus on learning the work sequence well. This is how we work on the main power supply of the bridge. Next, let's talk about these auxiliary power supplies of the bridge. We mentioned in the last class that this is the main power supply of the bridge. Let's take a look at the U7740 IC, which is the main power supply for the bridge. Its output voltage out is 1.05 volt, which is marked here. There are two other ICs that are also its auxiliary power supply, and their principles are the same. Take a look, there is another U7770 which outputs 1.5 volt. Several of their ICs, including the 1.5 volt SO LDO. The U7780 IC's output is 1.05 volt. In other words, none of the three auxiliary power supplies of the bridge will work without one. When we are searching if the main power supply is normal. Also look at this auxiliary power supply, same working principle. Then we take one of them to analyze. Those two of us will no longer waste time analyzing this thing. Let's take this 1.05 volt SO. What does this IC have? The power supply comes in 1.8 volt. Take a look. Let's draw a picture. After triggering, 1.8 volt comes in. And there is a 3.3 volt coming in. In other words, after you trigger, the two electricity must come first. These two electricity should come in at the same time. After coming in, it will have a switch signal, 3.3 volt switching signal. The second step, this is 3.3 volt. If there is no 3.3 volt, you have to follow this signal to find which circuit generated the upper level. With these two incoming signals, two incoming power supplies. Then the first pin inside the IC will output a 1.05 volt. This is our third step. Also mark 1.05 volts on the picture. Then 1.05 volt output will see the internal of our bridge. The EC pin is our anti pin, no need to consider. Everyone, look at this 7 pin is the temperature detect. This is mainly to detect the temperature of the IC. So the IC will not work if the temperature is too high, which plays a protective role. In maintenance, generally we don't look for this pin, we focus on these 3 pin. Is there any problem with the key position of the 6 pin, 4 pin, and the 3rd pin? If all 3 come in normally but don't output, it means that the IC itself has been damaged. Or this C77A1 leakage will also cause this voltage to not output. We test whether the capacitor is short-circuited. If there is a short circuit, deduct the capacitor directly. It may not be so if it is deducted. It's caused by the bad end, just change the IC or replace a bridge. So whether it is our U7780 or U7770, look at this picture and its expression, their principles are the same. I won't analyze it here. This is how the power supply of the bridge works. After class, we should pay more attention to its working process. Let's stop here for this class. Okay, let's move on the circuit from the previous lesson. After we trigger the memory power supply analysis is completed, and the bridge power supply we had just analyzed. When the bridge power supply is normal, next we analyze our CPU power supply. Then the CPU and the bridge are integrated, but its power supply still had no work independently. Then let's analyze the voltage required by the CPU. Our main CPU requires 3 sets of voltage. The first one is called CPU VCCIO voltage, auxiliary power supply. Here we call it pull-up power supply of the CPU. This is the first voltage. Let's analyze the power supply first. In addition, the CPU has a main power supply. Generally, it will write Vcore, which is expressed in English. Vcore means CPU main power supply. There is another case. Some laptops have this power supply, some don't have it. Some laptops have, others don't have. It is a power supply for the graphics card inside the CPU. In other words, although the entire CPU is here, some laptops have this power supply and some don't have it. The key seems to be whether there is a graphics card inside the CPU or not. There were those with graphics card and there were those without graphics card. If you don't have graphics card inside CPU, it won't have this power supply. The power supply will appear with graphics card inside the CPU, called AS3. There is another called VGA core. Different brands have different labeling methods, but the principle is the same. The latest laptops are basically like this now. Our analysis also analyzes from these 3 circuits. These 2 share an IC. This circuit is an independent chip circuit. Generally, its design is the same. When we repair, first check our CPU VCCIO voltage, and then check these 2 power supplies. So when repairing, we first talk about how the CPU VCCIO voltage is generated. Next, look at the next drawing. Let's take a look at the auxiliary power supply of the CPU. Let's take a look at this drawing in English. Its English name is the CPU VCCIO 1.05 volt. And it is generated in the S0 state. So let's look at this composition through the circuit. There is the first chip, the main power supply of the bridge and auxiliary power supply chip U7600 of the CPU. There is also a set of upper and lower transistor Q7630 and a large charging inductor L7630. Then there is a precision resistor R7640 here, which generates this volt. When you measure this inductance, it should be 1.05 volts. Then this circuit is mainly produced by the U7600 controlling the upper and lower transistor. Here we need to figure out the generation of the upper and lower transistor. So let's see how the U7600 works. Its working principle is the same as the memory power supply and the main power supply of the bridge we talked about last time. Look at this structure. As long as there is a chip like this, upper and lower transistor are large inductors. Their working modes are the same, but the working voltage is different. The repair method is the same. Then if you look here, you will find the 5V main power supply. 12, 13 pin and 14 pin respectively. This C7601 is easy to break. You can remove it without installing, including this resistor R7600. It is an insurance function of 2.2 ohms. These two are relatively easy to break. When you repair the machine, you must know that it's 5V. Needless to say, the upper transistor comes from the common point. I also talked about the voltage of the 8.5V the last time. Send it here first. It will be there before we trigger the power on. After there is a switch here and the chip is powered. This is the first step. Then the third pin of the EM receives the switching signal 3.3V. In addition, it will also generate an oscillating signal, the second pin. This oscillating signal pin, the resistor and capacitor cannot be dropped. Pay attention to these components. If it is dropped, it will leakage and it will automatically power off, but its failure rate is not high. After receiving this switch signal, receive this chip again. The 10 pin of this chip will output square wave. This is the second step. This is the third step. The output square wave controls the charge and discharge of our capacitor C7630. And then C7620 power our boot pin through R7630. This capacitor cannot be less. The resistor is the same. Play insurance role here, but try not to short circuit when it loose. After it has this power, it resists the boot, which is also called excitation power supply. The output the square wave to control the upper transistor to turn on to charge the inductor. After the upper transistor is turned on, this is the fifth step. Then the sixth step is to control the upper transistor to be fully charged, and then the lower transistor to turn on again. The inductor and the lower transistor worsen and the upper transistor turn off, and the inductor discharges low. Then there is a precision resistor R7640, which detects the working current of the circuit. This R6740 manipulates a protective role to prevent the equipment from burning out due to excessive current. Well, has a FB pin inside. Let's take a look at this voltage feedback pin. Don't let these two resistors lose or drop. The connection between these two resistors is called the feedback resistor. Also, it's to say that this is a process of working circuit. Then when the inductor voltage is stable, this chip will finally output a PWRGD signal. Our 9th pin will output the PWRGD signal to tell the next circuit. Finally, the PWRGD signal will be output. The work of the circuit to complete. The other equipment is not important, we will not analyze. So in this circuit, the same reason. The most easily damaged is the resistor and the upper and lower transistor Q7630. Including our chip, the fused resistor on the periphery of the chip, and these boost capacitors. These components are relatively easy to break. When we are overhauling, we have to push the schematic diagram and point math for it to find and measure. For maintenance and replacement, which is the CPU of the I/O voltage, also known as the CPU pull-up power supply. Okay, let's finish analyzing the I/O voltage of the CPU, which is also called the pull-down power supply of the CPU. Then take a look on the main power supply of the CPU again. Take a look at the main power supply of the CPU. It may be scattered here. Let's go to know these components one by one. Take a look. It is marked PPV core on the inductor. This is English name representing the main power supply of the CPU. So this R7510 here is a precision resistor. When we are repairing the machine, the large inductor was next to the CPU. On this large inductor, it should be about 1.0 volts for the CPU. Then the inductor is connected to the upper and lower transistor Q7510 and Q7520. This set of upper and lower transistors is easier to break. Then the two MOSFETs, it connects to the G pole and connected to the chip. It connects to the 5-pin and the 4-pin of the CPU power supply IC. This is our U740, is the CPU power supply IC, the main power supply IC. We analyze the CPU power supply. We mainly analyze how the CPU main power supply IC works. This chip is relatively easy to break. It relies on the chip to control the CPU power supply upper and lower transistor. Charge and discharge the inductor and generate the voltage required by the CPU. Then through the precision resistor to detect the current and then into CPU internal. So let's take a look at this CPU power supply IC. It has some difference on the working principle between the RAM and the bridge power supply IC. But they have something similar. Let's take a look and then analyze it. You look at the 5V CPU power IC, it also needs power. It normally supplied by the 5V and given to the 14-pin of the chip on this side. Another way is through a 10 ohm resistor. This insurance resistor is also easier to burn, then it was sent to the 24-pin and 15-pin of our chip. In other words, it should be 5V if you measure it, because it's marked as a 5V on the diagram. When repairing this resistor, we must focus on measuring the resistance of it. It is relatively easy to break. Its error value is 5%. 100 ohm can only be 5 ohm away. For 10 ohm, we will place them at 9.5 ohm. This resistor cannot be shorted. Then after power supply, the chip needs to receive EN signal for the same reason. The first pin must receive the EN signal, which is also 3.3 volt. This is the second step. This CPU EN signal generates the circuit here. We will not analyze it in this class. The circuit in the math is very different from the ordinary notebook. We will focus on analyzing how the EN signal is generated in the next lesson. It is also generated in the internal of the CPU. If this signal does not have 3.3 volts, it is also a problem with the CPU in all likelihood, because we talked about the I/O voltage of the CPU in the last class. It is sent to the inside the CPU after receiving the CPU 1.05 volt inside the CPU. If the outputs a switch signal to our CPU power chip, make it work. Only had this electricity is not enough. This is the first step, and then the second step. There is also a key signal pin when we are in the actual repairing. There are VID pin here. These conditions are used as a third condition. Here, VID is the voltage identification signal. The chip is used to identify the frequency of the CPU for internal operation. How much voltage does it need? It is mainly connected to the pin of the CPU connector, which is connected to the CPU. Generally, when we are repairing the board, we can check whether the CPU is damaged by testing the dial value of these pins. This is the third condition. And then fourth condition. And then what did it receive from us? Exciting power supply pins BSTB also receives voltage. This had to be output. This excitation power supply must be received. With these conditions, our chip starts to output square wave, from which channel is the square wave output. UGATE1G is the G-pole of the upper transistor. LGATE1G is the G-pole of the down transistor. It is output in the form of the square wave. When we repairing the machine, the two transistors are connected to the upper and lower transistor. Let's look at it on the other way around. This is connected to the G-pole of the upper transistor. The two transistors are connected in turn. This is the G-pole of the down transistor. If the chip is in contact with the above signal, it does not output the square wave to the G-pole of the upper and lower transistor. It means that the chip is also damaged. If there is no voltage above 1.0 volts on the inductor, then first check whether the upper and lower transistors are damaged. If the upper and lower transistors are not damaged, the failure rate of the inductor is not high. Basically, inductor refers to a measuring point. It is not easy to damage. If there is no 1.0 volt, test whether there is a problem with the upper and lower transistor. If there is no problem with the upper and lower transistor, check the chip immediately. Components of the disk key pin, including VID pins. You can see the VID pin connected to these two resistors here. Don't drop it. Like this resistor, if these conditions are checked, there is no problem. Including these two capacitors is also relatively easy to break. It plays a filtering role. It is come from the 5 volt. These two capacitors can be removed without installing. Focus on checking here. After this chip works, it will generate two signals to go out called P good. The 9-pin outputs P good, which is 3.3 volt. Why is this P good output used? It is mainly to turn on the next clock circuit to control the work of the clock circuit. Because if this P good does not go out, our next circuit will not work. So when we talk about the clock circuit, we'll talk about the P good circuit. We must first understand it. This is the process of how the CPU main power supply works. Look at the power supply of the internal graphics card in the CPU. Let me analyze the circuit together. Take a look at the power supply of the graphics card inside the CPU. It says PPV Core SO ASG IEG. In this, its inductor is L7550. It is also a voltage of 1.05 volt, which is a precision resistor. If you measure this inductor, if there is no 1.05 volt, that means we need to check whether the Q750 upper and lower transistor are damaged. If the upper and lower transistor are not damaged, we follow the G-pole of this field 2 to find our 3rd and 5th pin. Take a look, this is from CPU power supply chip. It outputs a square wave to this chip. This is a G-pole of the lower tube, and the G-pole of the upper tube is here. If there is no square wave on this two pin, the same reason is that our chip has been damaged. Then the chip in the CPU control two power supply field 2 at the same time. One is the upper and lower tubes for the main power supply of the CPU. One is to control the work of the upper and lower tubes of the internal graphics card power supply of the CPU. After the internal graphics card power supply of the CPU is received, here, let's take a look. It will also output a good signal. CPU MVP ASG is a good signal. We have to measure the voltage on this inductor when we are pairing. As long as any group of large inductor voltage is abnormal, because our laptop can be triggered, but screen no bright. When we repair, we first check the memory, and then check the bridge and check the voltage of each inductance of the CPU. Here we want to talk about the voltage of the major inductors. This class is over here. See you in the next class. Okay, so far the circuit working voltage of the major inductors on our MacBook. We have also analyzed their circuit parts. During maintenance, as long as the voltage of any inductance circuit is abnormal, we cause our laptop to fail to run the display, which is also called no power on, which means it can trigger but no display. According to the last few lessons we have learned, after triggering each major inductor voltage, what does it contain? We have mentioned it before, and now we make a conclusion. This is convenient for it to be flexibly used when repairing in practice. Let's summarize what else is there. The 3V 5V large inductor is the first to come out. It must work first. In addition, there are two large inductors on the RAM circuit. One is 1.8 volt, the other is 1.2 volt. Then there is a 1.05 volt large inductor of our bridge. There is also a large inductor for the power supply of the CPU. It includes a 1.05 volt auxiliary power supply CPU VCCIO. And the CPU Vcore voltage, the main power supply voltage of the CPU has 1. However, some laptops may have 2, which are mainly distinguished by the English expression. 2 of them are also connected in parallel and work synchronously. Don't let the change in the number affect our analysis. We should see the drawing for details. Its voltage normally is about 1.0 volt. Because the CPU clock bit is different, its voltage parameters are not specific. There is also a 1.5 ASG voltage inside. In other words, after we trigger, you must first ensure the voltage of these inductors is normal, and then we can test some small auxiliary power supplies, including our bridge auxiliary power supply 1.05 volt S0, 1.5 volt S0. When we talk about the circuit, we have measured as long as one of these power supplies are normal. It may cause our laptop trigger but nothing show on the screen. But the most important thing is to learn these power supplies. This is the most critical thing after triggering. That is to say, this small voltage will occasionally cause no power on. Unless it is a short circuit that leads to no boot. As long as it is not short circuit, even if it does not work, it will not affect the boot. I must tell everyone about this, including the MOSFET we use to conversion between high and low level. These small power supplies are only for powering some device at the interface. It does not affect our booting, but the premise is that there is no short circuit. As long as one of the power supply is short circuit, it will cause no power on. Whether these are open circuit or short circuit, they will not turn on. Including DDRVTT, this voltage will also cause a black screen. Although it is not connected to the large inductor, the voltage is also very important. This is when we are repairing the machine, no matter what the laptop is. I don't care how many large inductors you have. In the drawing or open this point map and schematic diagram, I must first find the location of these large inductors and measure them one by one. But they must also be measured in order. 1, 2, 3, 4. This 4th step must be done. When encountering the abnormal voltage inductance, we will find its corresponding power supply IC. Figure out its working principle according to the drawing. Key signals pins such as VCC, EN, BOT, FB. These chips have several key pins, and we also know through our analysis of circuit. These chips have one thing in common. They all have upper and lower transistor. Also power supply, VIN or VCC. They all have an EN. EN is the default 3.3 volt. They all have a boot. and also FB. And some have PG as well. This PG is out after it was normally. Don't test PG because it is not power. If there is power supply but there is no PG, we have changed the power supply IC. This point needs to be in place for everyone. These VC pin related components are also relatively easy to break. The common principle of this power supply circuit is similar. The chip, the upper and lower transistor, and the components related to these pins is easy to be damaged in this circuit. To focus on the search, it is necessary to check with the help of a schematic diagram. We can visit casually. It is hard to find these key pins without drawing. Because the IC manufacturer is different, the pin position is different, so we have to use drawing to repair. This is a summary process of major power supply voltage.